Neutrals are required to be counted as current carrying conductors, as specified in the National Electrical Code, specifically Section 300.3 Bone. This is a critical aspect of electrical design and installation. When dealing with derated ampacity, it is essential to understand how it affects the calculated load and overcurrent protection. The derated ampacity is applied to the calculated load, meaning that the conductor's capacity to carry current is reduced based on the number of conductors in a raceway or cable. The overcurrent protection device, or OPT, must be sized based on this derated ampacity to ensure the circuit is adequately protected. This means that you cannot simply choose an overcurrent device based on the initial ampacity of the conductor, but must adjust for the derating factor. Now, let's discuss the limitations of current-carrying conductors in metal wireways. The National Electrical Code, in Section 362.5, stipulates that there is a maximum number of 30 current-carrying conductors in a metal wireway. However, this is dependent on the size of the wireway. For a 6-inch by 6-inch by 36-inch gutter, the maximum number of current-carrying conductors is actually 84. According to National Electrical Code Section 352.5a. To achieve compliance with the National Electrical Code, you have several options. Firstly, consider reducing the number of current-carrying conductors. This can involve redesigning the circuit to minimize the number of conductors needed. Secondly, consider repulling one or both of the 2-inch electrical metallic tubing, also known as EMT, conduits with more conductors, or consider using a larger gutter. This may be necessary if the existing conduits are not adequately sized for the number of conductors they contain. Thirdly, consider increasing the size of the gutter, especially if the existing one is undersized. Installing a larger gutter, for example, a 12-inch by 12-inch by 36-inch gutter, can accommodate the number of current-carrying conductors more comfortably. Lastly, derate the ampacity of conductors. Use the 75% derating factor, as specified in National Electrical Code Section 310.15b3a, for the number of conductors in the conduit or gutter. This will necessitate a lower ampacity rating for the overcurrent protection device to ensure adequate protection of the circuit. Let's delve further into the specifics of these solutions. When considering reducing the number of current-carrying conductors, it is crucial to analyze the circuit design. One common approach is to consolidate circuits where possible, minimizing the number of individual conductors required. This might involve combining multiple smaller loads onto a single circuit, provided that the total load does not exceed the circuit's capacity after derating. Another strategy is to optimize the routing of conductors. By carefully planning the layout of the electrical system, you can minimize the distance that conductors need to travel, reducing the overall number of conductors required. This can be particularly effective in larger installations where long runs of conduit are common. When repulling conductors, it is essential to select conductors that are appropriately sized for the load they will carry. This includes considering the ampacity of the conductors as well as the voltage drop over the length of the circuit. Using larger conductors can reduce voltage drop and improve the overall efficiency of the electrical system. When selecting a larger gutter, it is important to choose one that is appropriately sized for the number of conductors it will contain. The National Electrical Code provides guidelines for determining the appropriate size of wireways based on the number and size of conductors. These guidelines should be followed carefully to ensure that the wireway is not overloaded. The full capacity of the wireway must be considered to ensure compliance. When derating the ampacity of conductors, it is crucial to follow the guidelines provided in the National Electrical Code. The derating factor depends on the number of current-carrying conductors in the raceway or cable, as well as the ambient temperature. It is important to consult the appropriate tables and calculations to determine the correct derating factor for the specific installation. The derating factor must be applied to the ampacity of the conductors before selecting the overcurrent protection device. The overcurrent protection device must be sized to protect the conductors from overcurrents, taking into account the derated ampacity. This ensures that the circuit is adequately protected and that the conductors are not overloaded. In addition to these solutions, It is also important to consider other factors that can affect the performance of electrical systems. These include proper grounding, bonding, and overvoltage protection. Proper grounding and bonding are essential for safety and can help to prevent electrical shocks. Overvoltage protection can help to protect sensitive electronic equipment from damage due to voltage surges. It is also important to ensure that all electrical work is performed by qualified personnel who are familiar with the National Electrical Code and other applicable standards. Improperly installed electrical systems can be dangerous and can lead to fires, electrical shocks, and other hazards. Therefore, it is essential to hire a qualified electrician to perform any electrical work. Furthermore, regular inspections and maintenance of electrical systems are crucial for ensuring their continued safety and reliability. These inspections should be performed by qualified personnel and should include a thorough examination of all components of the electrical system. Any deficiencies should be promptly corrected to prevent potential hazards. When working with electrical systems, it is important to follow all safety precautions. This includes wearing appropriate personal protective equipment such as gloves and safety glasses, and energizing circuits before working on them. It is also important to be aware of the potential hazards of electricity and to take steps to avoid them. Electricity can be dangerous, and it is important to treat it with respect. In summary, understanding neutral conductor requirements, ampacity, derating, and wireway capacity is essential for designing and installing safe and reliable electrical systems. By following the guidelines provided in the National Electrical Code and taking appropriate safety precautions, you can help to prevent electrical hazards and ensure the proper functioning of electrical equipment. Always consult with qualified electrical professionals when designing or modifying electrical systems to ensure compliance with applicable codes and standards. Let's consider a more detailed example to illustrate the application of these principles. Suppose you have a 2-inch EMT conduit containing 35 current-carrying conductors, all of which are number 12 American wire gauge or AUG THHN conductors. According to the National Electrical Code Table 310.15b3, when there are more than 3 current-carrying conductors in a raceway or cable, the ampacity of the conductors must be derated. The derating factor depends on the number of conductors. In this case, with 35 current-carrying conductors, the derating factor is 0.50, meaning that the ampacity of the conductors must be reduced to 50% of their original value. The ampacity of number 12 AWG THHN conductors is typically 30 amps. However, after applying the derating factor of 0.50, the derated ampacity is only 15 amps. This means that each conductor can only safely carry 15 amps of current. Therefore, the overcurrent protection device protecting these conductors must be sized no larger than 15 amps. If the overcurrent protection device is sized larger than 15 amps, the conductors could be overloaded, which could lead to overheating, insulation damage, and potentially a fire. It is important to note that the derating factor applies to all current-carrying conductors in the raceway, including neutral conductors if they are considered current-carrying. In a 3-phase, 4-wire system, the neutral conductor is typically considered current-carrying because it carries the unbalanced current from the phase conductors. Therefore, the neutral conductor must also be derated according to the same derating factor as the phase conductors. In addition to derating the ampacity of conductors, it is also important to consider the voltage drop in the circuit. Voltage drop is the reduction in voltage that occurs along the length of a conductor due to the conductor's resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends that the voltage drop in a branch circuit should not exceed 3% and that the total voltage drop from the service entrance to the furthest point in the circuit should not exceed 5%. To minimize voltage drop, it is important to use conductors that are appropriately sized for the load they will carry. Larger conductors have lower resistance and therefore result in less voltage drop. It is also important to minimize the length of the circuit by locating equipment as close as possible to the source of power. In addition to these considerations, it is also important to ensure that the electrical system is properly grounded and bonded. Grounding provides a path for fault current to flow back to the source of power, which helps to protect people from electrical shock. Bonding connects all metal parts of the electrical system together, which helps to ensure that they are at the same electrical potential. Proper grounding and bonding are essential for safety and can help to prevent electrical hazards. When working with electrical systems, it is important to follow all safety precautions. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and energizing circuits before working on them. It is also important to be aware of the potential hazards of electricity and to take steps to avoid them. Electricity can be dangerous, and it is important to treat it with respect. In conclusion, understanding neutral conductor requirements, ampacity, derating, wireway capacity, voltage drop, grounding, and bonding is essential for designing and installing safe and reliable electrical systems. By following the guidelines provided in the National Electrical Code and taking appropriate safety precautions, you can help to prevent electrical hazards and ensure the proper functioning of electrical equipment. Always consult with qualified electrical professionals when designing or modifying electrical systems to ensure compliance with applicable codes and standards. Consider the scenario of a commercial building requiring multiple circuits for lighting and receptacle outlets. The initial design calls for running a significant number of number 12 AWG/THHN conductors through a shared conduit to consolidate wiring. However, due to the number of conductors exceeding the allowable limit without derating, and the physical limitations of the conduit size, a different approach is necessary. Firstly, instead of running all circuits through a single conduit, the design could be revised to use multiple conduits, each containing a smaller number of conductors. This reduces the number of current-carrying conductors in each conduit, potentially eliminating the need for derating or at least reducing the derating factor. This approach requires careful calculation to ensure that the conduits are adequately sized for the number of conductors they contain, and that the fill ratio does not exceed the limits specified in the National Electrical Code. Secondly, consider using larger conductors for some of the circuits. While number 12 AWG conductors may be sufficient for many lighting and receptacle circuits, using number 10 AWG or even number 8 AWG conductors can reduce the voltage drop and allow for higher ampacity without derating. This can be particularly beneficial for circuits that supply power to equipment that is sensitive to voltage fluctuations. Thirdly, explore the possibility of using a cable tray system instead of conduits. Cable trays are open support systems that allow for easy installation and maintenance of cables. They can accommodate a large number of cables and conductors, and they typically do not require derating of conductors unless the cables are bundled together tightly. Cable trays are often used in industrial and commercial buildings where there are a large number of cables and conductors to manage. Lastly, review the lighting and receptacle layout to identify opportunities to reduce the number of circuits required. This could involve combining multiple smaller loads onto a single circuit or using more efficient lighting fixtures and receptacles that draw less current. By optimizing the electrical design, it may be possible to reduce the overall number of conductors required, which can simplify the installation and reduce the cost. In addition to these design considerations, it is also important to ensure that the electrical installation is performed by qualified personnel who are familiar with the National Electrical Code and other applicable standards. Improperly installed electrical systems can be dangerous and can lead to fires, electrical shocks, and other hazards. Therefore, it is essential to hire a qualified electrician to perform any electrical work. Furthermore, regular inspections and maintenance of electrical systems are crucial for ensuring their continued safety and reliability. These inspections should be performed by qualified personnel and should include a thorough examination of all components of the electrical system. Any deficiencies should be promptly corrected to prevent potential hazards. When working with electrical systems, it is important to follow all safety precautions. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and energizing circuits before working on them. It is also important to be aware of the potential hazards of electricity and to take steps to avoid them. Electricity can be dangerous, and it is important to treat it with respect. Let's consider an example regarding the installation of a subpanel in a detached garage. The subpanel will supply power to various lighting circuits, receptacle outlets, and a small air compressor. The initial plan is to run a single 1-inch conduit from the main panel in the house to the subpanel in the garage, containing all the necessary conductors. However, upon further review, it is determined that the number of current carrying conductors required for all the circuits exceeds the allowable limit for a 1-inch conduit without derating. To address this issue, several options are available. Firstly, the size of the conduit could be increased to 1.25 inches or 1.5 inches to accommodate the larger number of conductors. This would require replacing the existing conduit and fittings with larger ones, which can be costly and time-consuming. Secondly, the number of circuits could be reduced by combining some of the lighting circuits or receptacle outlets. This would reduce the number of current carrying conductors required in the conduit, but it may also limit the flexibility and convenience of the electrical system. Thirdly, a separate conduit could be run from the main panel to the subpanel for some of the circuits. This would distribute the conductors between two conduits, reducing the number of conductors in each conduit and potentially eliminating the need for derating. Fourthly, the load calculations could be reviewed to ensure that the size of the subpanel and the feeder conductors are appropriate for the actual load. It may be possible to reduce the size of the subpanel and the feeder conductors, which would also reduce the number of current carrying conductors required in the conduit. In addition to these options, it is also important to consider the grounding and bonding requirements for the subpanel. The subpanel must be properly grounded to provide a path for fault current to flow back to the source of power, which helps to protect people from electrical shock. The subpanel must also be bonded to all metal parts of the electrical system to ensure that they are at the same electrical potential. Proper grounding and bonding are essential for safety and can help to prevent electrical hazards. The conductors must be run according to the National Electrical Code and local code requirements. When working with electrical systems, it is important to follow all safety precautions.